Hello all, welcome back to my YouTube channel. In today's video, we will be deep diving into the fascinating world of Numpy, a Python library for scientific computing. So in this particular video, I'll be explaining you all in detail about Numpy library, how we can perform the mathematical and scientific calculations programmatically using Numpy, a Python library. Numpy stands for Numerical Python. So now let's dive into the computer screen and discuss more about our today's agenda. Before that, if you are not subscribed the channel, do subscribe the channel and on the bell notification, and don't forget to comment below to the question which I'll be asking in this particular video related to NumPy. So guys, now let's start with our video. Recently I made a video on pandas where I have used Jupyter Notebook for execution, but I have showed you all the simple steps how you can use your Colab Notebook. But for this particular video, I'll be using Google Colab Notebook and I'll be explaining you all how you can execute the queries, or else you can say the Python programs. But if you want to use the Jupyter Notebook, you can have a look on the pandas video once, or if you want to learn pandas, then you can have a look on that particular video link in this particular video description. Now let's not waste our time, let's continue. So this is the agenda of this particular video. We'll be seeing what is NumPy and how to install NumPy, and we'll be creating and manipulating some arrays using NumPy. We'll be creating it, and we'll be seeing some of the operations what we can perform using NumPy, and aggregations in the sense sum, mean, median, mode, everything we'll be seeing. Then we will be checking about some of the universal functions. Then we will be entering into the advanced NumPy and we'll be exploring the advanced NumPy features. So now let's not waste our time. Let's start with our first topic. So our first topic is, what is NumPy? NumPy is a powerful Python library for numerical computing. NumPy stands for numerical computing, or else numerical programming in Python. It provides efficient way to handle large arrays and perform mathematical operations on them. So NumPy is widely used in domains such as like data analysis, machine learning, and even in data science. This is mainly used for the research field also, and for analyzing the data you can perform EDA in essence exploratory data analysis, and even feature engineering, and we will be using in many other fields related to data. So I'll be explaining all those in detail in the upcoming videos also. Now let us mainly focus on what we'll be doing in this particular video. So guys, now let's enter into our second topic, which is nothing but how we'll be installing NumPy. I'll be showing you all. It is as simple as the installation of pandas only. It's very easy to install, like how we used to install our pandas. So first let's connect our Google Colab. So I have just clicked on this particular connect. It's getting connected. Let it to connect. And don't worry guys, this particular notebook, or else you can say this particular Colab notebook, whatever I'll be working on this notebook will be available for you all at this particular video description. You can have a look on that and you can copy whatever details you require from this. Okay, so let me just copy and paste what is NumPy. This particular detail also, it will be very good enough for you to refer whenever you want again. So let me just copy this and paste the So what is NumPy? So I have just made the information a bit short so that you can easily read it. So you can have a look on this. Now let us see how we can install it. So if you are using your Colab, just give an exclamatory mark. When you give the exclamatory mark, this particular cell will be considered automatically as a command. What we'll be typing, that is considered as a command, what we used to enter in the command prompt, right? That same command it will be considered. Install, simple, and run this query. So you can see here, it's showing requirement already satisfied. If it normally, when you are using Colab, it will be by default installed in some cases. So if it shows that, then that means that it's installed already, or else it will automatically get installed. This is the same procedure for your Jupyter Notebook also. Whoever are using their Jupyter Notebook, you can use either pip install NumPy, and if you are using your Anaconda distribution, then you can use conda install NumPy. It's same. Okay. Now let's continue with our third topic, which is nothing but create and manipulate array. Before that, I have an important announcement for you all, introducing you all Python for financial programming, an ultimate online course designed especially for the non-technical background students or an employees who are trying to enter into the field of programming or data. This particular course will be very useful for you all. You will be learning complete Python in detail, and it's a beginner friendly course. The instructor is Ritvik. You can see here, he is the instructor. He has explained the concepts in a very detailed way and a simple format. Even he has break down the complex concepts also into a easy and useful way, and he has explained it with the help of a simple programming codes. You can have a look on this particular course. It contains just of 2.5 to 3 hours of video content and quiz and assignment. Once you complete this course, you will be even getting the certification for this particular course. So register now to avail this particular discount of 60%. He is providing discount for you all for a limited period of time. So just don't lose this opportunity. Register for this particular course and you can learn complete programming for finance easily. In essence, Python programming in the point of finance, you can learn it easily and you can even get certificate after completing this particular course. So now let's not waste our time. Let's continue with our topic in this particular video. So guys, first let's import NumPy as NP. So once we have done with importing this, then we'll start to create the arrays first. So you can see the third agenda is nothing but create and manipulate array. So first we'll be creating the arrays. I'll be showing you all how can we create the arrays. So let me just create the normal array for you all first. We'll be creating array from a list. So for that what I'll be taking array1 is equals to, I'll be giving it as np.array, and in this I'll be giving you all list of numbers. So what I'll be doing, I'll take just a normal example. So this is the normal example. Now if I go for array1 and if I run this, you can see here it has created it as an array. You can even check the type of, you can see here it is showing you all numpy.nd array. So you can easily create a array list of array elements, or else you can say that a variable which contains the array elements using this particular code. So we saw how we can create a normal array. Now I'll be showing you all how you can create the zeros of array, or else you can say 3 by 4 array in a matrix format. You can say 3 by 4. Let me just type the code and show you all, then you can easily understand. So let me just type array2 is equals to np dot zeros. If you have learned matrix in maths, you might easily get this right now. Once I execute this, so let me give 3, 4. So now if I run this, you can see it has created a matrix of array, or else you can say two-dimensional array. So you can see here, this is a two-dimensional 2D array where 3 and 4 are there. So in this you can see here 1, 2, 3, 4. 4 is our nothing but it's our list. In a list it should contain 4 values. So it's nothing, we have given zeros here, so it's showing zeros, 4 values. And you can see here this 3 means nothing but 3 lists, 3 separate lists. Like this you can create the different arrays. Even you can check the type of this particular array also. If I just check it, you can see here this is also array only. There is no changes in this. Now let us see, you can, like this you can even create ones also, but you cannot create 2s or 3s. Only this particular option is available for zeros and ones. Equals to np dot ones, and I can give for this, let us try something different for this, 2, 3. And now if I run this, okay, it's overridden, right? I have given array 2, so it's overridden. So, or else let me just change it to array 3. If I run this, you can see here, it is creating nothing but 2, 3 matrix, or else 2, 3, you can see here 3 values, and it should be in 2 lists. So we are giving 2 into 3 matrix format. It is creating in the form of matrix, mathematical matrix. If you refer about matrix a bit, you can easily understand about this. So you can even create the array with a range of values also. Let me just give a name for this all so that you don't get confused. So where is this? Yeah. This is nothing but creating a normal array. So when it comes to this, you can see this is nothing but creating an array of zeros. And this is creating the array of ones. You might ask me why only ones. You can create 2, 3, 4 like this also, but you cannot create it. There is no particular function for that. Only these particular functions are available. Function instance like this, ones and zeros like this, it's not available for creating. You can try to create custom arrays, but you cannot create like this. So now we'll be creating an array range of values also. I'll be explaining you all about that. How you can create the array with the range of values. For that, what we'll be doing, array 4 is equals to np dot a range in essence array range of 0, 10, 2. So creating an array right now. So what we'll be doing, array 4. So let's run this. You can see here from 0 it should take the range till 10. So in between this it should create the elements, a list of elements. So you can see here it's skipping like in between this particular 2 we have given to skip in between 2 elements. So between 0 and 2 1 is missing, between 2 and 4 3 is missing. So it's creating in that particular range. So you can see here 0 to 10. In between these two values, 0 is our minimum number, starting number you can say, and 10 is our ending number. In between these two, it should create a random range of elements. So you can create like this a random range of elements also. So now we are done with creating. So we will be seeing how we can even manipulate the array. For that, what we will be doing now, let me write down that first here, that we will be manipulating. So manipulation is not that big task. So we will be seeing how we can manipulate right now. For this, what we will be doing, we will be using array 1 only. We have created array, right? So we will be using that only. So this one we have created using np.array, right? So we will be using this particular function. Why I am using array 1? Because this array 2, array 3 and 4, these all are created using different functions. Normally we use np.array to create n number of elements. You can create many elements using this. So we'll be using that. So right now we already have these values, right? So using this particular variable only, we will be doing the manipulations. Variable instance is array 1. So for this, let us perform some manipulations. Before that, I have a question for you all. Without seeing the further video, if you know the answer, you should stop this particular video here only and you have to comment this. You can see here, right, this particular 4. I want you all to answer me in which index number this particular 4 is available. So just stop the video and comment below. In the continuation of this particular video, I'll be explaining further. So print, let me type a code for you all, then I'll ask you the question related to that. Array 1 of 0. Let's take 0. So now if we run this, it's giving you 1. Can you all say me why? Because normally what happens in Python list, or else you can say in anything, list or tuple or anything, when you all be storing something, right? It will be stored in the index format. That in essence, like normally the index starts from 0. It doesn't matter what value you are giving, but it starts from 0. Now you can see here, this particular number is starting from 0th index. 0, 1, 2, 3, 4. So now we have 4 index values and 5 numbers. You are getting my point? 4 index values and we have numbers from 1 to 5. So this, if you give here, like for example, I asked you about 4, right? Let me just show you all that answer also. So now if I check for third index, you can see here, the 4 is at third index. I gave you all the output, but before seeing this only, you should comment below. So this is at the fourth index. You got my point? So now let's continue further. Even you can perform other operations also in this. For this, what you can do, print. Like you can get certain part of operations, not more than that also. For this, let me continue. Array 1. So in this, I want the numbers from second index to, or else let us take from first index to third index. Nothing more than this. So what it is showing, so our first index is 2 and our third index is 4. So before that, what is there? This is the number. So this is the number. 2 and 3 are the values which are available until our third index. So if you give here for fourth index, then it will show you we have 3 values, 2, 3 and 4. So fifth index it is not showing because it is until there only, not that also is not included. You are getting my point? So this is our second operation. Like this you can perform the slicing operations easily. Like if you have n numbers, like you have a data of 50 numbers, from that you want only randomly 10 numbers, then you can use the range function, right? Here this array range, and from that you can randomly generate like how many values you want. Between 0 to 50, I want only these many values. So like this you can generate and you can slice in between them. These are nothing but manipulations. And even you can do other operations also, like manipulating other operations like modifying. You can even modify the existing element also. So to modify, what we can do, so to modify this, let me write the code for you all. So arr1 is equals to, in this I want to modify the second index. So the second index number right now it is 3. So I want that number to be 9. I don't want 3 to be there. So what I'll be doing, I'll be just storing like this directly and I'll be modifying. Now let us see arr1. So if you run this, you can see here 1, 2, 9, 4, 5. So that particular number is modified. In a sense, it's removed. You can alter the number if you don't want that. You're getting my point? So that's all, guys. Creating an array and manipulation of array is done. Manipulation and modifying, it's done. So after this, what it comes, that is nothing but operations. We'll be discussing about operations now. So I have mentioned operations already. So for this, what we'll be doing, operations are nothing but we'll be performing some arithmetical, logical and exponential operations using this particular array only. Like we'll be performing some mathematical operations. So let us see how we can do that. For that, let's write the code freshly. So array importation is done. So let us store in array1 variable. We'll be storing p dot array. So in this, I want the list of 1, 2, 3. Only 3 elements are enough for me. So now I want to create the second array also. What I'll be doing, I'll be just copying this. I'll be just copying this line. Paste it here. So here what I'll be doing, I'll take 4, 5, 6. So it will be easy. And I'll name this array as second array. So let's run this. So now we have 1 and 2 array elements. So for this, what we'll be doing, so element wise arithmetic operations. So let us do some arithmetic operations for this. So we can do arithmetic operations for this, like addition, subtraction. We can do it. I'll show you all how you can do it. This is the very basics of that. So result 1 is equals to np dot array of sorry, result 1 is equals to, we'll be taking array 1 plus array 2. So this will give me the output of the addition value for this. And let us even write two more also so that it will be easy. Result 2 is equals to, in this I want to store addition is done, 1 multiplication of array 2. So result 3 is equals to, in this I want to store array 1 division of array 2. So now if I run this, we will be getting the output for all this. Let me show you all. Let's run this, it will be easy. So you can see here, result 1 is this. So result 3. You can see here we are getting the 3 results also. So first result will be 5, 7, 9. So you can see here 4 plus 1, 5, 5, 6, 7 and 9. And when you do multiplication also, 4 ones are 4, 5 twos are 10, 6 threes are 18. So you got it. And when we perform division, so it is getting in the float values. If you perform division, you will get to know this easily. So you can perform like this some basic arithmetic operations using NumPy. So this is done. Now let us even perform some aggregation also. You can even perform aggregations also easily. Aggregation. Yeah, aggregation is our next topic, right? So for operations, it is that much only. So NumPy is not going to take that much of time. NumPy, this particular video will be a bit short only compared to pandas, but we can understand complete NumPy easily in this particular video itself. So aggregations, we'll be seeing about aggregations here. So in this what we'll be doing, we'll be using the same whatever variables we have created, result, array 1 and array 2. And for this we'll be performing the aggregations right now. So what we'll be storing, result 4 is equals to, we can use like np dot sum. So there are some functions, okay, you can see here sum, np dot sum of array 1. So if I run this, yeah, let me to enter this and result 4. So you can see here it is showing 6. So when it comes to our array 1, okay, you can see here 2, 1, 3. So if you find the sum is nothing but we'll be finding the total, right? Total instance addition only, right? So 2 plus 3 plus 1, that is nothing but 6. You can find the sum. You might find this particular operations easy right now, operations and aggregations easy right now. But when you will be handling the large data set, right, then you will understand like what is the issue and everything. Now you can see here and you can calculate. But when there are n number of elements and n dimension of arrays, so in that if you want to calculate, then this sum and other aggregation functions will be very useful for you all, because it will save your time and it can easily calculate faster. So now sum is done. Now let's perform some more aggregations also. Result 5 is equals to, and for this what we'll be doing, we'll be finding the mean, np dot mean, median, mode. So they are like this, right? Mean of array 2. Okay, we'll be finding the mean of array 2, array elements 2. Okay, so for this what I'll do, let's take array 2 here and let's print res 5 also. Okay, what is this? Yeah, okay. You can see here. So 4, 5 and 6. So it's finding the mean. Mean is nothing but 5. If you know the mean, median, mode, mathematical operations, right? So that only we are doing using these aggregations also. You can see here. So the value of result 5, the output is nothing but from this it's finding the mean as 5. 5.0. It's giving in the float values. Integer, float, you know all this, right? I guess if you don't know, you can have a look on my Python course, which is available in this particular channel itself. And that particular playlist link will be in this video description. You can have a look on this and you can learn about that in detail. I have explained there in detail about what is this mean, median, mode and other operators, bitwise operators and many other operators. And that even advanced concepts like oops, inheritance and everything. You can have a look on that. So let's see, complete this first. So result 6 is equals to, and in this I'll be taking, let's take array 1 itself so that we can complete it faster and even you can understand easily. So from this what result 6 what I want is right np dot max of array 1. Print result 6. So what we'll be doing when we found the maximum number, even we want the minimum number, right? So we'll be taking res 7 is equals to np dot minimum of array 1 print. So now if I run this, you can see here from this the maximum value or maximum number from this particular array 1 list is 3 and the minimum value number is 1. You can see here, right? You can easily find the minimum, maximum, and even there are many other operations to explore in this particular aggregation function. You can easily understand that. I would recommend you all to see that and you can get it easily. So that's all for this particular aggregation function. Now let's continue with our next topic, which is nothing but universal functions. So universal functions. For this, we'll be using something called as U functions. So guys, here in universal functions, what we can do, we can even perform some trigonometric functions and exponential and logarithmic functions. You can say that you can easily perform that calculations also easily. You don't need to do any practical coding or anything. You can easily do that with this universal functions one library is there. You can do with that. So we will be seeing how we can do that. So first let us create an array for this freshly. Array is equals to np dot array of, so I'll be taking 0, 0th value, comma, so np dot pi. So you can see, you can even see like what is this pi it represents and everything. You can have a look on that. If you Google that, you will get it easily. Pi is nothing but in mathematical function you will be using, right, something called as pi. So that only, that particular pi, here it's defined as np dot pi. It's available in numpy, comma, again we need np dot pi. So here what we are doing, we are taking the 0 value and pi by 2 and again we are taking pi. For this we'll be performing some operations right now. So I'll show you. First we'll see how can we perform some trigonometric operations, basics. I know you might be feeling a bit difficult. It's not an issue. Just try to explore it. You will get it. So let me just show you all. Trigonometric functions or operations, you can say. So what we'll be doing, result 1 is equals to, for this what I'll take np dot sine. You will be knowing, right, sine theta, cos theta, everything. Sine of array variable. So if you check this, so you can check here. So it is showing the values, sine values. Sine of this particular variable, it's nothing but this is the values. You can see here. So you can create like this many things. Like even you have something called as cos. Let me show this as a here itself. I don't need to type again. I'll just make the edit here. Result 2. Sine we saw, right? You have cos, tan, everything is available. Cos. So if you run this, you can see here 1.000, something like this, and 6.123. You can see here. So you can see here like this. It's creating some minus 1.00. It's creating the values. It's finding the cause of this particular values which we have given. For 0, it's finding out, and for pi by 2, and for pi, it's finding out everything the values. You can even check programmatically if you want. You can perform the calculations and you can have a look on this. And for this also. So even there is something called tan, and whatever functions are available in trigonometry, right? Everything is available here in NumPy. You can have a look on that. So now let's go to exponents and logarithmic functions. Logarithmic functions, okay. So for this, what we'll be doing? So result 3 is equals to, we'll be taking that same array, np dot exponent of this particular values is nothing but, we'll be running this. Before that, let me to type result 3. So this shows the exponent of that particular value. It's taking time. Yeah. So it's showing 1.0. You can consider this as 0, and 4.81 is the exponent of pi by 2, and 23.1 is the exponent of pi. You can have a look on this. So once we are done with the exponent, now let us even see here how to perform logarithmic also. Let's copy this only. So for exponent, we use the function called as exp. And when it comes to logarithmic, we can directly use log. So log of this particular variable I want. That's all. Result 4. So let's run this. You can see here it's showing the output here, and it is even saying that Python input minus 38 point values, and it's showing that runtime warning divide by 0 is encountered to the log result 4. It's showing that there is an error while performing this particular operation. So it's showing here minus infinity. So only it's giving you the error also, that it's showing my 0 division error. So it cannot perform the 0, right? Normally when it comes to programming, you cannot perform 0 division. So if you try to do that, it will throw you the 0 division error. So it is showing that for the first one. So it's showing here infinity. We gave 0, right, in the values here. 0. For this, it's showing infinity. And for pi by 2, it's showing this is the value 0.45, so on. And when it comes to pi, it's showing 1.44144, so on. Like this, you can perform many logarithmic operations also if it's required. Normally, this is not require more. If you are performing some mathematical operations and if you are dealing with some financial related values, then this is required. You can have a look on this in detail. So that's all. This is all about this one, aggregation and operations, and even universal functions also are covered. This is all about universal functions, what we can be used in this particular code. Okay, so let's now dive into our final topic, which is nothing but we will be seeing some advanced NumPy features. So guys, in advanced NumPy features, we have different functions we can perform. So let's discuss about each and every functions in detail slowly one by one. First, let us discuss about broadcasting. So broadcasting allows NumPy to perform operations on array with different shapes. So shape of that particular array will say, right. So let me just show you all an example. So let us for example, ARR dot shape. We have three values in that, right? So we can see the shape. It is showing 3 comma 0 because it's one dimensional. It is nothing more than that. So it is this like this we can see the shape. But when it comes to broadcasting, it can allow different shapes to perform. So let us see about that. For that, what we will be doing. So for this here again, we'll be creating one new array so that it doesn't get confused for you all. Dot array of 3, only till 3. So copy this and enter 2 is equals to here, again paste it. So now what we'll be doing, we'll be again giving this in the form of 2D. 1, let's change the value also. 4, 5, 6. So this is done, right? So let us run this first. Let us save this. Now what we'll be doing. So result is equals to 1 plus. So you guys, can you guess what it's going to happen now? 1 result. Okay. So let's run this. It's nothing but it has created something like this. So you can see here 2, 3, 4, 5. It has created a two-dimensional array, and inside this it has saved like 4 plus 1 5 and 4 plus 2 6. It has created nothing but it has created one two-dimensional array, but inside that it has added every values accordingly what we have told. Like it has created a matrix right now. 3 by 3 matrix you can say, and two-dimensional array. So inside this you can see here 4 plus 1 5. So 5 is here, and 4 plus 2 6 7 7, and 4 plus 3, sorry, 4 plus 2 6, and then 4 plus 3 7 you can see here. So it has created something like this 4 5 4, yeah, 5 6 7 5 6 7, and when it comes to here 7 8 7 8 and 9 here. So it has created with every values. You're getting my point. Like with the help of broadcasting, you can do something like this. You can create the metrics by with the help of those particular 2 or 3 arrays which are available. We can create some metrics. So even you can do array masking also. We will see how we can do mask, or else you can say like you can hide the original details and you can mask it like filtering. Enable filtering and modifying the array values based on the conditions. So for masking, what we can do, I'll show you all how you can do that. For this, what we'll be doing, we'll be taking again one array. Array is equals to np.array, and inside this I want 1 comma 2 comma 3 comma 4 comma 5. So normally this will be my array. And now what I'll do, I'll create a variable called mask. So inside mask, what I'll do, so I want to store whatever values which are greater than 2 in that particular array, and apart from that I don't want anything else. So you can say this is nothing but this is a boolean mask. So inside this mask, what it inside this, it should save something which is greater than 2 array values. So now what I'll do, result is equals to array of, inside this I want mask, only mask values. So now what I'll do, it's nothing but we are applying the mask, or we are filtering the values from that particular array whichever it's having. So now once we check result, finally you can see the answer is nothing but 3, 4, 5. So the values which are greater than 2 are 3, 4, 5. So it has created a mask, and inside that it has imported. Like this, you can create a mask. You can enable filters, not only greater than, you can give less than or equal to, or you can even say that not equal to condition, like this. So you can perform something like this. Even there are something like sorting and searching operations also. We are about to end this particular session. In essence, we are about to complete the advanced tutorial. Only two topics are left out. Let's cover that and the NumPy tutorials is done. So let's see about sorting and searching. So for sorting and searching, what we'll be doing. So let's again create one array here also. So inside this array, what I'll be doing, I'll be giving the values randomly. Like I don't want the same values, like in an order I don't want. We want to sort it, right? And even we want to search it. So what we'll be doing, I'll give 5, 9, 4, 3, 1, 2. Something like this. I have created a randomly an array. Okay. So inside this, what I'll be doing now, we'll sort the array. Sorted array is equals to, inside this, what I'll do, there is a function called np dot sort. So using this function, we can sort the elements which are available inside that. So using this, you can perform sorting. So sort array is done. Now what we can do, we can even perform some indicates. Sorry, indices. We can even create a variable called indices, and inside this we can store something called as np dot argument sort, I guess arg sort. So you can see here there are different operations. Arrange is there, average is there, array to string. You can convert the array values to string, and you can even check argument max, min, and partition, sort, where everything is there. So what we'll be using, np dot arg sort, and inside this, what we'll be doing, so we'll be giving our array here again. So we'll print indices, and finally what we can do, so index of 4. So here what we'll be doing, we'll be searching whichever, let me complete this. So it will be index np dot search sorted. So this is a function search sorted, and inside this we'll take array comma 4. So print index of 4. So these are different functions which we are performing. So you can see here, index of 4, you got the value of 6 sorted from this. Okay. Uh, so you can see here, this is sorted 1, 2, 3, 4, 5, 9. So first operation is done, and from this indices we want arg sort. Arg sort is nothing but, let me to check it, arg. Yeah. So arg sort is nothing but a function, okay, which is indicating the sorting of an array. It returns an array of indices along with the given axis of the same shape of the input array. So it is just sorting and it is giving the indices and shapes. You can see here. So 1, 4. Okay, you can see here it is nothing but it's showing the index of that particular number at which particular indices it was stored. Like for example, see index of 1. So 1 is stored, it was previously stored at 4th. Okay, it was stored at 4th index. Okay, then when we sorted it came to first, and when it comes to 5, sorry, second, 2 was at 5th index. 3 was at third index only. So 5 is here. So you can see here 5 is at our 0th index. It is nothing but arg sort is nothing but it's showing the indexes or else indices of that particular value. And when it comes to search sort is also nothing but it is just showing the fourth index of 4 values. Yeah. So guys, that's all. So this advanced features for this it's done. Now we are left out with something called as the final topic. So which is nothing but input output. So we'll be seeing finally input output. You can even save whatever you're doing, right? You can save it in a form of a model and you can later load it. Let's check this. So for this, let us take, I guess we already have the code here. Let's use this only. Copy 1, 2, 3, 4, 5. So for this, what I'll be doing, we'll be saving that particular array as a file. For that, what we can do, np dot save. You can see here right now there is no files present except this sample data. np.save and inside this I'll give that file name array1 and I want to save arr. So when we run this, you can see here now this is saved. Let me refresh this. You can see here arr1.npy. Like this you can save it. You can save whatever values inside this particular thing. You can save it. Now if we try to open it, it's in numpy, right? So it's not able to open. You can load this file again. So input is done, sorry, output is done. We have saved the file, we have saved it successfully. Now we'll see about input, how we can load that particular file which we have saved. So for this, what we can do, load arr. It's a variable. So inside this variable we want to load that file. np dot, there is something called load function. When we have save function, so we'll be having the load function also. So what we'll be doing, we'll be loading this particular file arr array1 dot npy. So this is the file name. So when we run this, you can see here it has been saved successfully to this particular variable. Now if we check this particular variable, you can see here it is showing the array. You are getting my point. So guys, that's all. That's all. This only NumPy is all about this particular 7 topics. So we have finally covered all this topic. The agenda is clear. I hope you all understood very well about NumPy. So guys, that's all for today's video. Do like, share and subscribe the channel and on the bell notification and encourage me to do more videos like this, and do comment about what is your opinion on this particular video. So guys, that's all. Bye bye. Thank you all. We'll see you all in the next video.